Go.
Hey, happy Tuesday. All right, let's get started. You flip to page 9. So it should say fractions, part 2 at the top, page 9 in your book. All right, so it looks like this. And I'm going to start with mix to improper and improper to mix. So get mad and get mad. This is my favorite one. All right, so you can see represented in the picture is 1 and 5/8. So remember to pause and copy this down or copy it down as we explain it. All right. So you have your one whole, which is the whole 1. And then you can see that your fraction circle is split into 8s. And of those 8s, 5 are shaded in. So that picture is showing 1 and 5/8. But we want to make it mad, which means you multiply, add, and then the denominator always stays the same. So it's just those 3 simple steps. So we're taking 1 and 5/8, we're making it mad. We can see that it's going to equal 13 eighths, but let's go over here and oh, it's not over there. All right, so 8 times 1, so you take the denominator, 8 times 1 is 8, and then you add 8 plus 5, that's 13 eighths. And then over here in your little get mad box, we have another example, which is 2 1/3, and that is equal to 7/3. So the steps, you say 3 times 2 is 6, and then you add that product that you get from multiplying the whole number in the denominator to the numerator. So 6 plus 1 is 7, and then the 7 is your new numerator, and the denominator always stays the same. Okay, so now we're doing opposite. And if you remember our anchor chart, it was glad. So make them glad, happy. You're doing the opposite of making them mad. And most of the time, your answers are usually in mixed numbers, but sometimes on test questions, they'll be left in the improper format. So if you're using multiple choice, like on the back, like you will be in a minute for these, make sure you look at how the answers are presented. So 12 fifths. If you're going opposite, you're dividing. It's just like a division problem, which is pretty simple because we already went over reviewing that before. So the numerator goes inside the house, and your 5, which is the denominator, is the divisor. So when you divide, 5 times 2 is 10. So you can take 2 whole groups out. So 2 times 5 is 10. You subtract, and 2 is left over. The tricky part is remembering how to set it up. So remember, the quotient on the top of the roof is how many holes. So that's your whole number, 2 holes. And then denominator always stays the same. So fifths is moved over and written beside the 2. And then your remainder, which also happens to be 2 in this problem, is now the numerator. For these, I always quickly check. So like we did on the top, 5 times 2 is 12. No, 10 plus 2 is 12. Ooh, I'm tongue-tied. Whew. Okay, so the answer for 12 fifths is 2 and 2 fifths. Lots of numbers. All right, moving on to the next one. 15 fourths, again, you're dividing. So 4 times 3, 3 holes, is 12. So 3 goes on the top of the roof. You know that's going to be your whole number. And then you subtract 12 from 15, you have 3 left over. What stays the same? The denominator. So go ahead and write your 4 as the denominator, and the 3 is the remainder, and also the whole number again in this one. That's funny. And so that one goes on the top of the 4. So 3 and 3/4, again, check. 3 times 4 is 12, plus, did I say that right?
Yep.
3, yep. Plus 3.
Yep. Is 15 fourths. You did it perfectly.
Yeah, I don't know. I thought it was going to be 16. I'm crazy today. Ignore me.
It's been a long week.
Yes. Okay, so then 22 divided by 3. I'm already thinking in my head factors of, I'm already thinking like 21 times 7. No, my gosh.
Do we want to
erase, delete, go back? My head is thinking too much, and I've really messed this whole thing up. I'm really sorry, Miss Patterson, but we're going to keep going. Teachers
Are
are
we?
not
Okay.
perfect, especially in this weird format. Okay, stay focused, Miss Moore. So 22 divided by 3. You set it up. You know 7 times 3 is 21. That's where my brain was already going. So I already knew the answer before I could explain it. And then, so 7 is your whole number on the top. So you write 7, and then you only have 1 left over. So 1 is your remainder. What stays the same? The denominator. So your answer is 7 1/3. So you always want to check your work. 7 times 3 is 21. Add that 1 and it's 22/3, which is equivalent. Sorry.
That was awesome. We're in a rut. We're trying to get this done in less than 16 minutes. That's the problem. All right, the bottom part, adding and subtracting fractions. In 4th grade, you will always have denominators that are the same. In 5th grade, you're going to have denominators that are different. So you have to understand this part before you move to 5th grade. Some of the choice board activities have unlike denominators as a little challenge. So if you're up for the challenge, find equivalent fractions and add them or subtract them. All right, most important thing, never, ever, 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 ever add or subtract the denominators. The denominators stay the same. I'm going to hide this for a second. You can see in this example, I have 1/4 plus another 1/4. They stay fourths, so my denominator stays the same. I now just have 2/4. Down here, I'm subtracting. I have 3/4 minus 2/4, which leaves me with 1/4. So that's kind of why the denominator stays the same, but never, ever, ever add or subtract the denominator. So we're going to start out pretty easy over here. We have 2/5 plus 1/5. If I think about those as pictures, I can think about these problems over here. 2/5 plus 1/5 would just be 3/5. When I'm adding mixed numbers, I start with my fractions over here. 1/4 plus 3/4 would give me 4/4, which we know is 1 whole. So I'm going to hang on to that for a second. Then I add my whole numbers. 6 plus 5 is 11. 11 plus 1 whole equals 12. We save 2 boxes for subtraction because it's a little bit harder. So this one's kind of a basic problem. 7/8 minus 5/8. If I need to, I can draw a rectangle, shade in 7/8, and then eliminate 5 of them. And I would see that I had 2/8 left over. I also know that with adding and subtracting, I have to either change mixed to improper or improper to mixed, and also simplify. So 2/8 is okay, but 1/4 is the best answer because I can divide by 2 in the top and bottom. When I'm subtracting mixed numbers, and it's just a nice, easy problem, I have 3/4 minus 1/4, which gives me 2/4. I'm going to keep it like that for now. And then 5 minus 2 is 3. So my final answer is 3 2/4, but I know 2 and 4 are both even numbers, so I can divide them by 2 in the top and bottom, and I get 3 1/2 as my best answer. Over here, my original problem was 16 minus 5 3/5. So I know that if I don't have anything up here at first, I can't take 3/5 away from nothing. So I have to borrow a whole and add a whole. So remember, we're just rewriting the fractions as wholes. So this becomes 15 5/5, which is equivalent to 16 whole. Now I have a fraction to take away my other fraction. 5/5 minus 3/5 is 2/5, and I needed to borrow from him just like with regular whole numbers, so now 15 minus 5 is 10. The bottom one is the most complicated problem you'll have in the 4th grade. It started out as 10 1/4 minus 5 3/4. Make sure you pause the video and write that down because we're moving pretty quickly. I have 1/4 here, but I can't take 3/4 away from that 1/4. So I need to borrow a whole from my 10, he becomes a 9, and then I need to add a whole to what was already there. So 1/4 plus 4/4 gives me 5/4. And if you think about what Ms. Moore just said with changing fractions, I know 5/4 equals 1 1/4, which is exactly what I did here. I took away a whole and I had 1/4. So now I'm just using this 5/4. It's still equivalent, but now I can take away 3/4, which gives me 2/4. And then 9 minus 5 is 4. Again, I have two even numbers. I know that 2 is half of 4, so I need to simplify that to make it 4 1/2. So by the time we left fractions for the year, you guys were all doing really, really well with this. The only things that we need to remember is we've got to be very neat. If we are borrowing, we need to mark it out. That was the most common mistake. We would accidentally do 16 minus 5, but we needed to take away from that 16, so it's really 15 minus 5. So just super careful and just be neat with your work so that you don't make any silly mistakes with that.
Yeah.
Anything to add?
Then for the last one, she showed my class would always forget to add that 1/4 that was already there after you move that whole over. So that step could mess up the whole thing.
Yep,
Miss
exactly.
Patterson.
You too, Mrs. Moore. All right, take a minute to solve these 6 problems, please. Pause the video and then come right back. Here we go.
Great. First one, you are adding these two mixed numbers. So when you stack it up neatly, you add only the numerators. We start with the fractions. So 1 plus 2 is 3. Denominator stays the same, so that's 3/3. And then 5 plus 2 is 7. You're not going to leave it as 7 3/3 because that's weird. We know 3/3 is equal to 1 whole, so 7 plus 1 equals 8, which is B.
Good. Number 2 is one of the tricky ones. So I'm going to set it up by stacking it. I know that I can't do 1/8 minus 2/8. So I've got to borrow a whole and add a whole. So now I have 9/8 minus 2/8 is 7/8. And then 9 minus 7 is 2. Remember, we can always plug it back in to check it too with addition.
Awesome. All right. And then number 3, what is the sum of 12 and 4/6 plus 4 and 1/6? This one's great because you don't have to really do anything complicated like with the subtracting. So 4, we're adding the numerators is 5. 5/6 looks great to me. And then 12 plus 4 is 16. And I'm thinking of divisibility rules. I'm thinking, can that be simplified? I know 5 and 6 do not have a factor of 2. So yes, you can divide 6 by 2, but 5 cannot be simplified any further. So C, 16, 5, 6 is the correct answer.
Perfect. So on number 3, they said the sum, but then they were really nice and they set the problem up for us. On number 4, they say the difference, but then they don't set it up for us. So I just have to remember that the difference means to subtract. So this one's 13 and 4/6 minus 7 and 2/6. I don't have to borrow anything. I just do 4 minus 2 is 2/6, and 13 minus 7 is 6. And I know all of you Rockstar students went ahead and simplified it. You knew that 2 and 6 were even. You divided by 2 in the top and bottom, and you got 6 1/3. But then when you looked at the answer choices, you went, oh no, it's not there. But that's because they made a mistake. They should have simplified. They didn't. Mrs. Moore and I are very mad at them. We're going to write the company, make them fix it. But A is the best answer.
Yes, correct. All right, and 5 is kind of like all the way back to the place value question. So you're underlining or circling like we did in the problem with the 2 4s. And we have a 4 sitting in the thousands and then the 10,000s place. So it's asking how many times greater is the 4 in the 10,000s than the thousands place. So if you're picturing a number line, it only jumps 1 to the left. So that's 10 times greater. As you move to the left, it's 10 times greater. So B, 10 times greater is the answer.
Perfect. And then number 6 is kind of a tricky one. I'm adding those two together, but when I do 5/8 plus 7/8, I get 12/8. So I've got to use the strategies that Mrs. Moore taught me earlier in the video. I have to see how many times 8 goes into 12. I get 1 4/8. I'm just kind of holding on to that for a minute. 15 plus 18 is 33. I've got to combine those 33 whole to the 1 1/2 that I got from the 12/8, and I get a final answer of 34 1/2. And that's it.
And they didn't simplify this one either, man.
Oh, you're right. I'm really upset. I know. I bet our
So
fourth graders did a better job.
Half. So.
All right. We good?
We're done.
Have a great day. See you later. Adios.